Hi, this is gonna be another example for 2D equilibrium. So hopefully you have already get a hang of how to work on it, and through this example you can start to do it with me at the same time. Okay, so this is a problem to determine the drag force at a given speed on a prototype sailboat, and this model is placed in a test channel, and the tension is 40 in AB and AE is given. So in order to do the FBD diagram, that's our first step. I'm just going to draw on here. So A is where I'm curious about all the forces acting on. They already told us the forces in tension AB is 60 is actually 40 pounds. So this I'm going to draw A to B. This is kind of sign convention I'm using. So start on A and ends with B. So that's going to be the direction, and it's 40 pounds. And they also said the tension in AE, cable AE is 60 pounds. So we're going to draw like that, right? So that's TAE 60 pounds. So those are the two tension, pull point A in those directions. And any other forces? Yeah, there's a cable AC that's pulling as well. I'm sorry. So there's another tension right here, and we're going to call TAC. And we do not know. That's what's one of the two unknowns. And they said there's a drag force. Let's look at it. Flow is going this direction. If the flow is going this direction, and it's gonna it's dragging, right? So in that situation, the drag force is going to be pulling this direction, right? It's opposite of flow. In that case, I'm gonna move over here because I want to apply at point A. So that's what we're gonna call the drag force, and I can call it let's see, I'm just gonna call FD, the drag force. Those are the four forces in this FBD. Now we're going to write down our equations. Again, throw away the training wheel, start to put all the x components in one equation. Now let's see, if we start with TAB, and TAB is 40 Newton. It might be worth for us to isolate that out. And this is TAB, it's 40 pounds. And do we know the angle here? We know, they just say alpha, beta. They didn't tell us the angle. So what do we do for this situation? Previously, we have always given the angle. This problem has its own uniqueness. What is it? They didn't give us the angle, however, they gave us a geometry because they give us this is 7 foot, this is 4 foot. Well, can we find out the angle? We can. We can certainly find out the angle. Though the question for you is it necessary to find out the angle? Can we just use this length to help figure it out? This is something new. So first of all, if we were trying to find out the angle, the method number 1, so I'm not ready for this yet. So method number 1 is finding the alpha. Alpha, if we're looking at this triangle, this is 7 foot, apostrophe means foot, and 4 foot, and this is our alpha. So we know tangent to alpha is 7, opposite over adjacent, 7 over 4. So it's going to be inverse tangent of 7 over 4. Then you can find your angle alpha. And if I do so, I put it into my calculator, 7 over 4. And do inverse tangent of that. Then that gives me the answer. Angle is 60.255 degree. Okay, so knowing that, then I can go ahead, look at this TAB, which is 40 Newton. we need to go ahead and find its x component and y component. Then we can figure it out. The TAB x component is going to be this 40 pound, this hypotenuse, and this alpha is right here. X direction is opposite, so it's going to be sine this alpha 60.255 degree, right? And it's negative because it's pointing to the left. So if we do so, I'm looking at that. So it's 40 times sine 60.255 then I have answer as negative 34.73 pound. So that's my x component. Then I can do the same thing for my y component, right? So y component will be TAB y component, and it is adjacent to this alpha, so it will be 40 times cosine 60.255 degree, and it's going up, so it's positive. So we have cosine 60.255 times 40. That gave me an answer as 19.85 pound. So those are the two components of x and y. This is one method, method number one. You can do that, but I will encourage you to start thinking about method number two in the future. Instead of going to the angle, how about we just using the geometry? Let's see how we do that. So you have this TAB 40 pound. We're going to decompose to x component and a y component. That's our TABx and TABy. And we know this has this geometry, 7 foot and 4 foot. We don't worry about the angle anymore. And the first thing I want you to do is figure out this hypotenuse. Since this is 90 degree, right? So the hypotenuse, we're going to call H hypotenuse. That's going to be equal to square root of 7 squared plus 4 squared, right? And knowing that, we can go ahead and calculate that. So we have 49 plus 16 and take a square root of that. We get an answer as about 8.06 foot. Then we're going to find TABx, which is this one. And be aware, this triangle right here, it's the same as this triangle here, right? They're symmetric. They have the same similar triangle. So in that situation, if I want to find this x component, which is right here, this x component will be parallel to this 7 foot, right? 7 foot is right here. It's x direction. So I'm going to use proportionality. So watch out. So it's going to be 7 over hypotenuse. The hypotenuse you just find out, 8.06. So in this triangle, I'm using the geometry, using the length, 7 foot right here, over this hypotenuse, 8.06. And in this triangle, going back to this one now, remember they are similar, they are proportional. So in that situation, we're going to I'm going to get rid of that. So that's going to be equal to, in this triangle right here, I'm solving TABx. That's also x direction corresponding to 7. They are both x direction. And the hypotenuse in this triangle is what? TAB, 40 pounds. So in that situation, I can, in the future, just quickly using this to solve it. TABx, it's going to be 40. 40 times a fraction. What's a fraction? Horizontal, 7 foot, over hypotenuse, 8.06. Okay, so in the future, just that force you are trying to dissolve, then times x component over hypotenuse. X direction length over hypotenuse. In that situation, so we have 280 divided by 8.06. Then we'll get an answer as 34.74. Right? It's the same. You said there's a tolerance, okay? Because here our angle is rounded, and here our hypotenuse is rounded, okay? So that's going to be that much. Of course, this is going to go in left also because it's going to the left, so it's negative. So the same thing you can solve TABY. And in this situation, I'm going to just write down our equation right away. TABY at y component, it's going to be this 4 foot, right? Because it's y, so it's 4 foot over hypotenuse of 8.06, then times this TAB 40 Newton. That's it. Then you see how quickly this is going to be instead of solving the angle now. Then we got 19.85, which is the same as using the angle. So I want to encourage you to go ahead using the method number 2 now when the angle is not provided, instead the geometry is provided. Okay, so then you got the TABX and TABY. The same thing, you can find the TAC. Okay, so in that situation, we are going to look at the TACX. TACX, we're going to use in the geometry, and we're going to copy down here. This is our TAC. We don't know the angle, but we know this is 1.5. Right here, 1.5 foot. And we know this is 4 foot, right? So using that similar triangle we just discussed, we can figure it out. TAC X component. TAC is unknown. We're actually solving it. So this will be our TAC. We're going to figure out the fraction on the X component. X component, do we use 1.5 or 4? 1.5 because it's X direction. And we just need to figure out the hypotenuse. Hypotenuse will be 1.5 square plus 4 square, right? So put into calculator 1.5 square plus 4 square, and we take a square root of that. We get an answer as 4.272. So that's 4.272. Then that's going to be, you look at this TAC, when you decompose, you get X component and Y component. So they're both going to be positive. Okay, now the next, we're going to figure out TACY. That's TAC times Y component. Then we're going to use 4 now because it's Y component. It's vertical direction over hypotenuse, which is 4.272. Okay, and then we have our TACX and TACY. Now I think we're ready to construct our equation for this one now. Sum of all the forces at X direction, there are 4 forces. Now let's start with TAB. TAB, we already know the X direction component is that, so negative 34.74. Since TAB is known, so we have exact number for X component. And now we're going to move to TAC. TAC, we just have an expression right here. It's going to be plus 1.5 over 4.272 times TAC. Now let's look at the next force, TAE. TAE is going downward, so there's no X component, so that'd be plus 0. Then the last force is FD. FD is your solving, we do not know, and it's going to the left. It's dragging the flow, so it's negative FD. That equal to 0. So in this equation, you count for all the X components of the 4 forces. Now let's look at forces at Y. Again, we start with TAB first. TAB, we already have y component as 19.85 Newton. And is that positive or negative? It's positive because it's going upward, right? TAB is going left and upward. Now next is TAC. Our TAC, we already have expression for y component, so it's going to be plus 4.272 times TAC. Now let's look at our TAE. TAE is going downward, so it's going to be minus 60. That's the y component. And we know FD, being drag force, is perfect horizontal, so there's no y component. They're going to be plus 0, equal to 0. All of them together. And then you have those two equations. Then the rest is solving that. Again, I'm going to take a quick picture, and then we're going to this Wolfram, trying to solve it. So the first one is negative 34.74, then plus 1.5 over 4.272, then times TAC. Well, we cannot use two equations. I'm just two symbols, two letters, what I mean. So I'm just going to use T, okay? That's my tension. Then plus 0 minus F. So T and F are my two variables, equals 0. Then the next equation is going to be 19.85 plus 4 over 4.272, then times T, then minus 60. That equals 0. Those are the two equations, and enter it. Okay. So let's take a look. The equation looks right. It's translated right. And the second one looks right too. And they give us answer already for F and T. So I'm going to take a picture and go back to the OneNote. So then my T is TAC. That's giving us 42.8802. Okay. Then my drag force F D is 19.6838, and it's a negative value. Interesting, huh? Because why do we get negative value? And now I'm thinking about this problem. In order to get this boat to be equilibrium, this drag force is actually the force dragging the boat caused by flow. It's not a friction. Okay, earlier I interpreted as friction, so I thought it's going to go in this way. However, it's actually the force that's pulling the caused by the flow that's pushing it forward in this direction. So even though there is misinterpretation, and this does not hurt your answer. Why? When you get negative value, which means initial guess on the force, the direction was wrong, but it's okay. Why? Because your FBD is showing you, I said it's going to go into the left. When I get negative value, then I know it's actually going to the right. So you don't need to go back to change the direction here in your FBD, and you answer with a negative value already telling us it's going to be going to the right. So this is what happens quite often when you're solving equilibrium equation. When you get negative value, don't panic. It's totally all right. What that tell us is just the direction, what we assumed in the FBD should be the opposite. And here you don't go ahead to change the direction now because your answer is paired with this original FBD you have. That already explains the force direction. For this situation, it means just going to the right for the drag force. And hopefully that helps. You're going to see more examples on that in the future. And I'm glad that we actually encountered this one right now. All right, so this is a great example because it shows the angle not given. Instead, the geometry is given. Then you can go ahead using geometry, using that proportionality to figure out XY component. And another learning point for this is when you get a negative answer, it's totally okay. It's just corresponding to this FBD. All right, hopefully this is helpful, and I'll see you at the next one. Bye.